so the next example, again, it looks complicated. It really does. There's a lot going on. I've got a 24x cubed. I've got a 2 plus x to the 4th, all inside the 5 raised to the 5th power, right? This whole group raised to the 5th power. And so it seems like there's a lot going on. But remember, the first step is to understand what's inside the other function. And so this 2 plus x to the 4th is inside the 5-degree power function. This is outside. And so when I set it up, u is equal to the entire expression, 2 plus x to the 4th. Right, then we take the derivative of that, du over dx. Well, the 2 will zero out. The derivative of x to the 4th is going to give me 4x cubed. Now again, there's 2 ways you can do this one. All right, and I'm going to solve it 2 ways, just to show you the difference between the 2 methods. The first method I'm going to use, again, it just depends on which one you kind of prefer. Where I'm going to kind of reorganize it. All right, so first of all, move dx over, so du equals 4x cubed dx. U is equal to that. Well, you'll notice I do have an x cubed, but I don't have a 4x cubed. I've got a 24x cubed. But I could rewrite 24, right? 24x cubed can be rewritten as 4 times 6, right? 4 times 6 gives me out 24 x cubed, right? I can rewrite this as 6 times 4x cubed, right? I didn't change anything. What I did is I factored, right? I took 24 and I factored it into 6 times 4. And then I'm going to rewrite it. I'm going to leave the 6 out front as a constant, and then I'm going to move the 4x cubed over here with the dx. Alright, so I'm just rewriting stuff. The 6 doesn't go, I still need it because it's a part of the 24, so the 6 is going to stay. The 2x plus x to the 4th raised to the 5th. And then I'm going to move the 4x cubed over here with the dx because that's it. Again, I didn't change the expression. I actually just factored it. Right? You'll notice I could multiply back to get me to the 24. If I took the 4x cubed and multiplied it with the 6, I'd get back to this 24x cubed. And so I didn't change the value of the expression. I just factored it into something that I can substitute. Now I can do my substitutions, right? This is equal to du. This is equal to u. And so when I substitute out, I get 6u to the 5th du. That's one way to solve it. All right, and again, if you're really good at sort of the factoring and figuring that out, that's one way you can solve it. All right, now I'm going to show you the alternative, and it's going to be sort of the same method that I used in the previous example. I'm going to get back to the 6u to the 5th, so that's one way you can do it. If you're comfortable with this method is one way to go. If you're not comfortable with factoring like that, you can use the same method that I did in the last video example. All right, this will always work. You can always solve for dx. All right, so if I solve that for dx, so I've got du equals 4x cubed dx. I get rid of the 4x cubed by dividing by 4x cubed. And so I get du divided by 4x cubed equals dx. All right, and so what I'm going to do is I go back to my original expressions. I'm going to rewrite it. Instead of factoring, I'm just going to move the 24x cubed over here with dx. So 24x cubed dx. And so instead of splitting it and factoring it, what I'm just going to do is, I'm just going to replace dx, and I'm just going to replace the inside function. I'm going to replace the dx expression and the inside function. I'm going to replace the inside function with the u, and I'm going to replace dx with u divided by x cubed. And it's important that you remember you have to put the whole expression u divided by x cubed. All right, so when I do that substitution, I get u raised to the 5th. The 24x cubed is still there, don't forget it. 24x cubed. And then I'm replacing the dx with du divided by 4x cubed. And so this is an alternative to factoring. Instead of factoring, well, you still have to do a little algebra. You have to do a simplification. I do have to simplify this division. And when I simplify that division, well, the x cubes reduce. I divide 4 into 24, and so I get a 6 du. And so you'll see, you get the exact same expression. If I rewrite the 6 out front, it's 6 u to the 5th du. Alright, which this is the function I can now take the antiderivative of. Alright, so the antiderivative is the power rule on my 5th degree. 6 is just a constant multiplier that comes along. And so I get 6 times u raised to the 6 divided by 6, which is actually, I needed that 6 because it reduces here. And so when I reduce that, I'm going to replace the expression with my u. So I've got to go back and remember what my u expression was. My u expression was 2 plus x to the 4th. And so f of x is 2 plus x to the 4th raised to the 6th degree plus some unknown constant. And there's my final answer. If I take the derivative of this expression, 2 plus x to the 4th raised to the 6th and some unknown constant, it will give me back to this expression. All right, you can check it out on your own. All right, so that's an alternative if you want to use that. I kind of showed you both methods here, and I'll kind of use them hand in hand because I think one method sometimes is easier than the other method when I go through my following example. So I'm going to do this second example here, and then I'll stop and pick up the next ones in my next video. All right, so this is kind of similar to the last one, but it's a little easier because there's no constants. There's the square root function. Inside the square root is a 1 plus e to the x. Well, that's what my u is going to be. Take the derivative of the inside. Well, the 1 will zero out. The derivative of e to the x is just e to the x. Move the dx to the other side. E to the x du. Or it's a dx. Sorry, du equals e to the x dx. And in this case, I don't really have to do anything special because I've got an e to the x. If I move it over here, I get the expression I want. So I'm moving the e to the x over with the dx. I'm going to rewrite my square root as the 1/2 power. Now I'm going to substitute out. Alright, so this I replace with u, and this entire expression gets replaced with du. So I didn't have to do anything. This is sort of like the first example. Everything simplifies and substitutes out nicely. So when I do my substitutions, I'm left with u to the 1/2 power du, and that's it, right? Because 1 plus e to the x replaces with u. The e to the x dx gets replaces with du. And so when I take the antiderivative of that, I use my power function. I get u raised to the 3/2. Instead of divided by 3/2, we multiply by 2/3, and then there's some unknown constant. And so replace back. 2/3 times the group, 1 plus e to the x, raised to the 3/2 power plus c. And there is my general antiderivative. Alright, so we'll stop there. We'll pick up the next examples in the next video.